This lecture is about creating new variables. Once you've loaded a data set into R, sometimes you'll find that some of the variables that you're looking for are not actually in the raw data that you've loaded in. So you may need to transform the data a little bit to get the values you'd like. Usually you'll add those values back into the data frame. This is particularly important when you're doing something like prediction, where you want to create new variables that you might use as predictors. Common variables that people create are missingness indicators, so pointing out where you might have missing data. That's one really common variable to create. Also, cutting up quantitative variables, creating variables that are factor versions of a quantitative variable, corresponding to particular values that might be of interest, or applying transformations to deal with data that have strange distributions. So we're going to be using this Baltimore restaurant data set as an example. So again, you could go to the URL and then click over here on this export button to get the URL for a particular version of the data set. In this case, I'm using the CSV version. Again, I see if the data directory exists. Then I download the file from the internet and I load it into R using read.csv. Now I've got a data set rest data, which is the restaurant data that was created from this data set. And so one thing that I'm going to talk about first before I get into analyzing the data set is creating sequences. Sequences are often used to index different operations that you're going to be doing on data, and so it's good to know how to create them. The command that you use in R is seek, and so usually what you do is you tell seek the minimum value and the maximum value, and then there's two ways in which you usually specify how many values to generate. One is to use the by command, so by equals 2 means it creates it starts at 1 and then creates new values, increasing each new value by 2. Another way to do it is to specify the length of the vector. And so what that means is it'll start at 1 and end at 10, and it will create exactly 3 values. A third way is to say, suppose you have a vector x and it has 5 values in it, and suppose you want to create an index so that you can loop over those 5 values. You might use the seek along equals x, which will basically create a vector of the same length as x, but with indices, consecutive indices that you can use for looping or for accessing subsets of data sets. So one kind of variable that you might want to create is a variable that indicates which subset another variable comes from. So for example, here we have this restaurant data. We actually have the neighborhoods that the restaurants are in. And so I might want to find all of the restaurants that are in 2 neighborhoods near me, Roland Park and Homeland. And so if I use this %in% command, it will allow me to find only the neighborhoods that are in those 2, or only the restaurants that are in those 2 neighborhoods. It'll return true if you're in that neighborhood and false if you're not. And then what I'm doing is I'm appending this near me variable onto the restaurant data set. So this allows me to now subset that data set only by the restaurants that are near me, which is kind of a nice clean way of subsetting the data set as opposed to always having to use this longer %in% command. Another thing you might want to do is create binary variables. So for example, we might want to find the cases where we know the zip code is wrong. So again, I'm assigning to the data frame the variable zip wrong, and here I'm using the if-else command. So for the if-else command, I first send it a condition. In this case, I'm going to send it the condition, is the zip code less than 0? So if the zip code is less than 0, we think that that zip code must be wrong. And so the first thing that I return is true if the condition holds true. So in other words, all the cases where the zip code is less than 0, I'll get a true. And then this is what the function returns if the condition is false. So if the condition is false, in other words, if the zip code is positive, then I get a false. So at the end of the day, what I can do is then make a table of whether the zip code is wrong and whether the zip code is less than 0. And you can see that in all the cases where the zip code is less than 0 or greater than 0, I get false. And in the one case where the zip code is greater than 0, or sorry, less than 0, I get true. And so that might be a value that I want to filter out of my data set. And this makes it an easy way to filter those values out. You also might want to make categorical variables out of quantitative variables. So for example, we might want to break the zip codes up into consecutive numbers. So here I'm going to create a variable that I'm calling zip groups. And so what I'm going to use is this cut command. I'm going to apply it to a quantitative variable, the zip code. And I'm going to tell the cut command that I want to break that up according to some values, a list of values that I give it. In this case, I'm going to break it up according to the quantiles of that zip code. So what that will then return is a factor variable. So zip groups is a factor variable where it will break the variable zip code up into the 0th quantile to the 25th percentile, the 25th to the 50th percentile, the 50th to the 75th, and the 75th to the 100th percentile. And so, for example, there are about 375 of the values that land between the 25th percentile and the 50th percentile. And so then what I can do is I can make a table that shows you which of the zip codes fall into which of these different clusters. And so you can see, say, the low values fall into the first cluster, and then the medium values fall into the next cluster, and so forth. So what this does is it breaks a quantitative variable up into a categorical variable. An easier way to do that, I had to specify all the breaks with the quantile function in the previous version of cut. If you go into the hmisc package and you use the cut2 function, you can actually specify, I want to break the zip code up into 4 different groups, and I want to break them up according to the quantiles. And so when I do that, it will actually find out the quantiles for me and break it up into 4 groups according to the quantiles, which is kind of a nice way to do it if you don't want to have to set the breaks in advance. So the cut2 function in the hmisc package. Another thing that you might want to do is you might want to create factor variables. So for example, the zip code variable is an integer variable when you load it into R, but you might want to turn it into a factor variable. In other words, it's not clear that incrementing the zip code by 1 changes quantitatively the variable. So you might want to turn that into a factor variable, and the way that you do that is with the factor command. So it takes an input of this integer variable and it turns it into a factor variable, which I'm calling ZCF. So if I look at the first 10 values of ZCF, it shows me these values, and they look just like they did before. They look like the values that are the zip code values, but then it tells me how many different zip code levels there are. There are 32 different zip code levels, and if I look at a class of this variable, it's a factor variable. So a couple of other things that you might want to know about factor variables. So here, what I'm going to do is I'm going to create just a dummy vector so that we can see some other properties of factor variables. I'm going to create a vector of yeses and nos, and so I'm going to do that randomly. I'm going to generate a size 10 vector of yeses and nos, and I'm going to turn that into a factor variable, and I'm going to, by default, what it's going to do is it's going to treat the lowest value alphabetically as the first value in the factor variable. But suppose I want it to treat the yes values as the lowest value, then I can tell it to take the levels and create them in this order. And so, for example, what I can do is I can re-level that variable and make the reference class be equal to the yes value. Another thing that you can do is you can use the as.numeric command to change that factor variable back into a numeric variable if you want to use it in certain kinds of models. This can be a useful thing to do. And one thing that it'll do is it'll start with sort of the lowest value and call that 1, and then the next lowest value and call that 2, and so forth. So cutting produces factor variables. We saw before that I wanted to create this zipped groups variable where I cut the zip codes up into 4 separate groups by their quantiles. And so if you make a table of them, you'll get to see this table, and the class of this object, zip groups, is now a factor variable. You can actually use the mutate function to create a new version of a variable and simultaneously add it to a data set. This is part of the plier package. So what I'm going to do here is I'm going to create a new data frame. This new data frame is, I'm going to apply the mutate function to the old data frame, and I'm going to add a new variable, zip groups, which is equal to a function of one of the variables in the original rest data frame. And so what happens now is the new data frame will be the old data frame rest data with the new variables added. So now I can make a table of the zip groups, and I can see that it appears in this new data frame rest2. Another thing that you're probably going to do with quantitative data is in an exploratory analysis, maybe apply some different transformations. So here's a list of the most common transformations, taking absolute values and square roots. You might take the ceiling or the floor if you want to round values up or down to the nearest integer. You can also use the round function to round to as many digits as you'd like, or the signif function to round to as many significant digits as you'd like. all the standard sort of calculator functions like cosine and sine are in R, as well as logs, which are commonly used when you have skewed data or data with a lot of outliers, and then you can also exponentiate data as well. There's a lot more about this at these two links that I've provided here at the bottom, Andrew Jaffe's lecture notes, as well as this stat methods page. Even more further notes are available from the Plier tutorial, as well as the lecture notes that focus on transformations from Andrew Jaffe as well.